I think this is also a good place to define natural logarithms and common logarithms. You're going to be practicing graphing logs, and these are going to come up. Now, let's start with the natural logarithm. You'll see that we have natural n logarithm L. Well, the natural logarithm can be written as ln. This is not an I, this is an L. In fact, let's make it really obvious for you. It's an L. So those of you who type into Pearson IN, it's going to look exactly like ln, but it's going to be wrong. This is a natural logarithm, NL. The natural log of x is log base e of x. This is very important. Whenever you see the natural logarithm, it means you have a log with a base e. What would be the points on this graph? Write them down here. Did you get those points? E is your base. Remember what we said about E? Close to 3. Don't forget you also have that vertical asymptote at x equals 0. The other log that often shows up is known as the common logarithm. We write the common logarithm like this. We don't write a base in. We don't bother writing a base. It's so common that mathematicians, scientists said, if we don't write it, we'll know what it means. It's kind of like with a square root versus a cube root. We don't write the 2 in here because it's so common. We don't bother writing it. Maybe we should call that the common radical. The common base is base 10. So whenever you don't see a base, we understand that it's base 10. Write the points on the graph for this function. Make sure you memorize those. By now, your bathroom mirror should be full of things I've asked you to memorize. You can add this to your mirror. You could put it on your fridge. Don't open the fridge to eat until you remember what ln means, until you remember what common log means. Let's do a little bit more practice graphing for this week. We're going to jump right in with a common logarithm, or sorry, a natural logarithm. Let's rewrite this. This is negative log base e of x minus 2. So we're going to start with that basic log base e of x. We know those ordered pairs, 1 over e negative 1, 1, 0, e1, and a vertical asymptote of x equals 0. We want to do that reflection next. Notice that I'm always writing the base e a little bit lower. Don't write it up beside, and don't write the x up high. Some of you will be doing that. You'll be writing log base e of x, or log, that doesn't mean base e. Remember, this means base 10. Don't do that. Be careful. Are we changing x or y here? Yeah, we're going to be changing y. So find these ordered pairs and then do the negative. Oh, I'll do these with you. Negative 2 is a bit difficult. Okay. No, I don't think so. You can do it. Find all the points for this graph. I was wrong, so I didn't ask you to find them all. Let's look at this. We know that we're changing x because this minus 2 is inside the function with x, and the opposite when we're adding and subtracting. So we have x plus 2. Well, 1 over e is not a very nice number, so we're just going to write 1 over e plus 2. Keep y the same. This one's easy, plus 2. This one, we're just going to write e plus 2. Y stays the same, but we're adding to our, oh, why did I go back to green? Just to confuse me. We're adding 2 to our vertical asymptote. So let's graph this. Make sure you label your X and your Y axis. Always easier to read your graph. Oof, that's not looking very good. And I like to put my asymptote in first. Oh, I think I should move my y-axis over. I'm going to do that. There we go. Okay, y equals 2. X equals 2. Maybe I've been recording too long today. Let's look at the graph. I'm going to start with that point that's easy to graph at 3, 0. That one's easy, right? And even e plus 2 is easier than 1 over e plus 2. Remember, e is close to 3 plus 2, so close to 5. So when we're close to 5, 3, 4, oh, I didn't draw this graph very well. I didn't give myself enough room. I think I'm going to move everything over just so that it's easier to graph. Can you see that this isn't always a straightforward process? Sometimes you erase things. Sometimes you do them over. That's okay. This is about practice and learning. Oh, I better get rid of that negative point there. Okay, x equals 2. Let's graph that. In fact, if you weren't starting over often, then you're not practicing enough. Starting over is just part of learning how to do the math, especially when the math becomes difficult. So what did I start with? 3, 0, 1, 2, 3, 0. There it is. E plus 2, close to 3 plus 2, close to 5, close to 5, negative 1. All right, 1/3, close to 1/3 plus 2. So if I'm at 2 and then 1/3 more, and that's at 1, I can see that this is my graph here. Remember, these don't have to be perfect. They have to be close enough. And if you have your key points written down, I know that you know where you're trying to get to. Let's try another one where we don't have base e. Let's just look at log base 4. Do you think you can do this one? I think so. We're going to start with log base 4 of x. These are our basic x, y coordinates. Why don't you see if you can find all of the points and graph this function? Did you put the negative on x? I hope so, because this time that negative sign is inside the function. That means we're changing our x value. What kind of transformation is this? We know when the negative is outside, it's a reflection across the x-axis. This is going to be a reflection across the y-axis. I'll let you finish up. So there we have our reflection, and it was also vertically shifted up 3 units. So we've started thinking about logarithms, but most of the practice for this week's review is exponential functions. Make sure you started practicing and preparing for your next test, which all helps you get ready for your final exam.